E, and here in right hand side what is the value? It is minus R by L into T. So as we know the basic rule of logarithm, that if the log here it is in minus, then what we can write? We can write log E as a common, and here we can write V minus IR and V in the denominator. And in the right hand side the value are put up as it is, that is minus R by L into T. Now again doing the applying the logarithm rules, we can write that this value, that is this log E, if we are putting this in the right hand side, so what will happen? We will get V minus IR divided by V is equal to E raised to minus R by L into T. So in this equation we can write V minus IR, and this V we are putting at the right hand side. So what is happen? The equation will become V minus IR is equal to V into E raised to minus R by L into T. So again we can put this V in the right hand side. So what will happen in the left hand side? It will be IR, and if we are considering V as a common, so what will happen? It will be V in bracket 1 minus E raised to minus R by L into T. So we can say that I is equal to V by R, and because see this R is put up in the denominator, so we can find out I is equal to V by R in bracket 1 minus E raised to minus R by L into T. So what is V by R? V by R is the maximum current that is flowing in the conductor, right? And what is L by R? L by R we can denote it by lambda. Okay, so here now let us see the graphical analysis. Let us assume that at this position, when I switch this switch close in the circuit, what will happen? If the switch is get closed, then obviously there will be some, after some time the current will get increased because the battery is connected, right? So what will happen? The current will gradually increase. If it is a purely resistive circuit, then what will happen? It will be a straight line, or the initial rate is equal to V by L. Now the current will growth likewise, and you can say that maximum current is equal to V by R. Now as we have from the derivation we have find that I is equal to Im in bracket 1 minus E raised to minus T by lambda. So which is, where is this component or this equation lies? It lies in this position. That means that in the inductor the current will increase exponentially. Likewise you have seen that in a capacitor, when it is get charged, the voltage will increase exponentially, but here in inductor the current will get exponential as per this equation. So you have to remember this equation, that is I is equal to Im in bracket 1 minus E raised to minus T by lambda. Okay, now if we consider that a lambda is equal to L by R, then it is nothing but a time constant of a circuit. So it can be defined by two ways. First is that it is a time during which the current would get maximum value, that is Im is equal to V by R, and it is maintain initially rate of rise, that is time taken is equal to Im divided by initial rise, that is V by R is divided by V by L. So V will get cancelled, so we will get L by R. But actually the current takes more time because of the rate of rise of decrease gradually. In actual practice, in a time equal to the time constant, that is it will reaches up to 0.632 time. How this 0.632 time come? Let us see. T is equal to L by R, we have denoted by lambda. So I is equal to Im in bracket 1 minus E raised to minus T by lambda. Now the value of E, what is the value of E? It is 2.718. So putting the value, in the equation we will get 1 minus 1 upon 2.718, that is 0.632 Im. Hence we can conclude from the equation that the time constant of RL circuit may be defined as the time during which the current will actually rise to 0.632 of its maximum steady state value. Or in percentage if we want to say, then we can say that the current that is increased will be 63.2% of the steady state value. So you have to remember this value in some of the examples. So the current growth in RL circuit, we can say that it will increase exponentially, and this time is called the time constant. Time constant is equal to L by R. So the delayed rise of the current in an inductive circuit is utilized in the providing time lag operation of the relay and trip coils. So that is the practical applications of the inductor circuit, that as the inductor is providing some time delay, so by using this time delay the electrical engineer can design a relay or a trip coil. So what is the function of relay? Relay will sense the fault and it will send the signal to the circuit breaker. So according to this relay operation we can do the breaking of the circuits. Now let us discuss the decay of the current in a inductive circuit. The decay of inductive circuit or the decay of current in a inductor, we can use the same circuit. In this circuit we will put this switch in the B position. So what will happen if we are putting this in the B position? Then it will be obviously a short circuited, right? So when this switch is connected to point B, RL circuit will get short circuited. If we want to find out the voltage drop across this, then we can find out VR is equal to IR, and if you want to find out the voltage drop across the inductor, then we can find out by the equation, that is VL is equal to L di by dt. Okay. So it is found that the current does not cease immediately. That means it will not become zero immediately. Okay, it would do a non-inductive circuit, but it will continues to flow and is reduced to zero only after some time. Obviously this time is theoretically infinite, but the practical time is approximately 5 lambda. What is lambda? Lambda is equal to L by R. So depend on the value of inductor and the resistor value, the current will become zero. It will not depend on the battery. Okay. So the equation for the decay of the current with the time can be find out by putting V is equal to 0 in the following equation. This one is the same equation that we have used in the rise of a current in a inductive circuit, right? What is the equation? It is di divided by V minus IR is equal to 1 by L into dt. Or in another way you can also write V is equal to IR plus L di by dt. The same equation is written but in the other form, or the some terms are rearranged in the equation. Okay. So the equation for the decay of the current with the time can be find out by putting V is equal to 0 in equation 1. So in our equation V is equal to IR plus L di by dt. So if you are putting V is equal to 0, then what will happen is the equation will become 0 is equal to IR plus L di by dt. So L di by dt can be put off in the left hand side, then in the right hand side. So what will happen? The equation will become di by I is equal to minus R by L into dt. Let us do the integration of both the side. So if we are doing the integration with both the side, what is the value we will get? We will get here it will be integration of di by I is equal to minus R by L, and in the right hand side it will be minus R by L integration of dt. So what is the integration of di by I? It is log I, that is minus R by L. In the right hand side it will be minus R by L plus K. So what is K? K is the constant that is done in the integration portion. So we will say this as a first equation. Now at the instant of switching off, the current will get maximum, and when we are doing the switch off operation in this circuit, let us see the circuit again. See, in this circuit, when this switch is in B position, what will happen? It will get short circuit, but at that time what will be the condition? The current will be maximum, right? So it can be written that I is equal to Im, and if the time is counted from this instant, then it will be t is equal to 0. So putting this value in the equation 1, what will be our value? It will be log e into Im is equal to 0 plus k. Okay. Now we can write that log Im base e is equal to 0 plus k, because in this condition what we have discussed, that t is equal to 0 and I is equal to Im, right? So what will happen? It will be log Im and base is e is equal to 0 plus k. So putting the value of k, what is the value of k now? Value of k is equal to log Im and base is e. So let us put in the equation 1. What was our equation 1? Equation 1 was this. It is log I is equal to r by l plus k. R by l into t plus k. So it will be log I base e is equal to minus t by lambda is equal to log Im and base is e. So what will be further equation become? It will be, if we are putting this logarithm term in the left hand side, so what will be it will become? It will be log I divided by log Im. In the right hand side it will be minus t divided by lambda. Are you getting? Now if we know that if we are putting this logarithm term in the right hand side, so what will be it will become? It will be I by Im is equal to e raised to minus t by lambda. So that is the same thing that is done over here, that is I by Im is equal to e raised to minus t by lambda. Now again simplifying the equation, how you can simplify? You can put I as a main, or you can simply move this Im in the right hand side. So it will be I is equal to Im into e raised to minus t divided by lambda. So what is lambda? Lambda is the time constant, or it is, you can say, a decaying exponential function, and it can be plotted in the graph. That means till now derivation portion we have derived this equation I is equal to Im into e raised to minus t divided by lambda. So this e indicates that it is a exponential function. That means the current will not get decrease immediately. If you want to find out a current decrease, you can put the value of time over here, and you can then find out how much current is decreased. So let us see this equation in the graph, or let us put the values in the graph and do the analysis of how the current is decreased in the inductor. So it is called decay of current in the inductor. So again putting the t is equal to lambda in the above equation, we can say that I is equal to Im divided by e. What is the value of e? Value of e is equal to 2.178. So what the equation will become? 1 divided by 2.718, that is 0.37 into Im. So if we are considering the same circuit, that is having resistor and inductor that are connected in series with a battery, and if we are switch on the circuit is switch on. Now if we switch off the circuit, so what will happen? The current should be decreased, or current should be actually in the resistive circuit it should be directly 0. But in the inductive circuit what will happen? As the switch is operated, that is, we can say that this one is the point, right? In the rise of current this was the point, but in the decay of current this one is the point that we should consider. So what will happen? the current will get decreased by some magnitude when the time is passes. Ideally the current will get 0 after the infinite time. So this equation, that is I is equal to I m into e raised to minus lambda minus t by lambda, is the relation that we can use to find out how much current is decay or how much current is get decrease. So here you can say that lambda is equal to r by l, right? So as from this equation we have find out that I is equal to 0.37 of the maximum current. So here if we do the percentage wise, then what is the value? It is 0.37. That means 37% is the value. So the current will get decreased from this point and it will decrease up to this time. So this time is denoted by lambda. So what we can conclude from this analysis, that time constant of a RL circuit can be also defined by the time during which the current will falls to a 0.37 second of its maximum steady state value while it is getting decreased. So this 0.37 is the value that you have to consider, or you can, in other words, you can also say that up to 0.37 time the current will get 0. That means if we are switch off the circuit, then up to this time the inductor will also have some current. It will not become 0 immediately. Now graph wise let us see. This one is the equation. The time constant for the RL circuit is tau, or we can also say that it is a lambda. Lambda is equal to L by R. The time constant is the time for current to decrease from 1 divided by E, that is it is inversely proportional. You can say that it is inversely proportional to its original value. The time constant is a measure of how quickly the current grows, or it will get decrease, or it will decay. So now let us solve some examples based on the topics that we have studied in today's lecture. In today's lecture we have studied